Hello everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. The topic for today's video is refrigeration cycle, right? So in my previous videos you have a look at refrigeration definition, what exactly is the meaning, how it is applicable in pharmaceuticals, how you define the refrigerant which is actually doing the refrigeration, what are its various types, what are the factors that we consider while choosing a refrigerant. Let's move forward to the next part, that is refrigeration cycle, that actually how refrigeration take place. Its basic components actually are condenser, compressor, liquid trap, evaporator and expansion valve. All these components work together to generate two types of pressures. One is high pressure vapor, other is low pressure vapor. So this high pressure and low pressure vapor, they are working generating continuously so that a continuous cooling effect can be produced, right? So the sequence of event is like, first thing is let's begin with the receiver or the condenser. This condenser is also known as receiver. Basically the liquid refrigerant is kept in a container, right? This container is called condenser. And this refrigerant is under pressure and vapor and liquid phases are in equilibrium when it is inside the condenser. So inside the condenser part, the refrigerant which can be converted into the liquid phase and which can be condensed back to the liquid phase. So in the condenser there is an equilibrium between its liquid phase and the vapor phase. Next thing is expansion valve, right? So from this condenser where refrigerant was stored, this will move forward, this vapor form will move forward towards the expansion valve. As the name is indicating, it is trying to expand the vapors, right? So it has a control over the rate of flow of refrigerant inside the evaporator. So how from this condenser to this evaporator, how the vapors will flow, so that will be controlled by this expansion valve. So this will convert the refrigerant from a high pressure to a low pressure zone, because as we expand something, its volume will increase and definitely its pressure will be decreased. So it works on the same principle. So the refrigerant now will enter in the low pressure zone. Next thing is next component rather I should say is evaporator. Basically this mixture of vapor and liquid that pass from condenser from a high pressure zone to a low pressure zone, this liquid and vapor mixture will enter evaporator, right? So this evaporator actually consists of coils, right? So it's a type of heating coil, like a heating mantle. Inside that, in a rod, the coil is there, electric rod which is used for heating. The same way in the evaporator there are rods, okay, or coils. What happens here is the refrigerant evaporates by absorbing heat from the space. The molecules move away from each other because ultimately, because of the energy they have taken, they have absorbed from the space, the intermolecular forces will be overcome, right? So the heat required for this process will be taken from the surrounding environment. Surrounding environment means the things which need to be cooled, right? So the heat will be given from those substances, like inside the refrigerator, whatever material we place, suppose we are keeping milk, so that heat at the normal condition like 37 degrees Celsius, and if I compare it with the temperature inside the refrigerator, that is 8 degrees Celsius, and in the freezer it is less than 8, right, or 2 to 8 degree cold conditions. So from 37 to 2 to 8 degrees, so there is a huge difference in temperature as well as in the heat capacity, right? So the hot substance, hot means normal condition, like milk I have put it inside the refrigerator, so there will be difference in temperatures, right? So comparatively the normal temperature milk will be hotter as compared to the ice or cool conditions, right? So that heat would be taken from the surrounding. Surrounding here means the things which are to be cooled, right? In this step, basically what happens, the liquid vaporizes completely because it is getting heat. Inside this evaporator there are coils, right? So that heat will be taken from the surrounding, and what happens, we were having the mixture of liquid and vapor here. So once it enters the evaporator, because of the presence of the coils inside the evaporator and the heat, right, from the surrounding, the liquid refrigerant will also evaporate. So the mixture of liquid and vapor is totally vapor now once it is exiting from the evaporator section. Okay. Next part is the liquid trap. A liquid trap is usually, as the name indicates, it is trapping something. That means what it is trapping, as the name is saying, trap. So liquid is getting trapped. So somehow if small quantity of liquid is still remaining inside the mixture, air water vapor mixture, so that would be removed. Okay, refrigerant basically. So this liquid trap will be used to remove the liquid, which is then returned to the condenser here. So whatever is unused, that means the refrigerant is existing in both physical forms. One is your liquid phase, other is vapor phase. So once it is entering or inside the evaporator, it was a mixture of liquid as well as vapor state, but once it is exiting, there is minute quantity of liquid. Once it is exiting from liquid trap, the liquid all will be trapped and sent back to the condenser, while the vapor will enter inside the compressor, right? So the compressor will actually work now. It will do the mechanical work. Actually there is a piston and conveyor system, okay, on what compressor actually works. So this circulation, whatever of the liquid and vapor is taking place, that is being done due to the compressor. So inside the compressor, the low pressure vapor is entering. So this saturated vapor is allowed to pass through the compressor. During this compression process, compression is added to the vapor and the pressure will increase. Okay, so once the volume is getting filled up, so that will increase the pressure, okay, as more and more vapors are entering inside the compressor. The compression is then adiabatic, okay, and on the discharge side it produces a supersaturated gas. This exit side, a supersaturated gas will be released. The valve from here should be opened very slowly. A part of liquid vaporizes to give the stream of high velocity, like in the case of pressure cooker. Once we release the valve, okay, what happens? Liquid evaporates at random to give the stream of high velocity stream. Okay, so this high vapor pressure then move to the condenser. So from here it is at high pressure. So the supersaturated vapor flows to the condenser, where what will happen in the condenser? They will lose their heat, reach to their dew point, and get converted back to the liquid state. These condenser can be air cooled or water cooled. That means air will be passed, circulated, and hot air will come out. Cool air will be passed, hot air will come out. Or you can say the cold water will enter and hot water will exit. So this is one complete cycle. I am repeating. The refrigerant is placed inside the condenser in the mixture form of liquid and gas. This, on using the expansion valve, will enter the evaporator, but at a low pressure. From this evaporator, it will take heat from the surrounding, that is from the material which is to be cooled, okay, and with that heat the remaining liquid will also evaporate, and once it is exiting from the evaporator towards the liquid trap, only minute quantity of the refrigerant in liquid form is present. That minute quantity in the liquid form of the refrigerant will go back to the condenser, and the rest of the vapors which are at low pressure situation will be sent to the compressor. The compressor will convert them into high pressure vapors, okay, and moreover it is also responsible for circulating the refrigerant throughout the unit, right? Once they are exiting from the compressor, they are high pressure vapor conditions, okay. Then they will move towards condenser, from where heat, with the help of heat exchangers or heat exchange, the refrigerant will be converted from the vapor state back to the liquid state, and this cycle will move on, right? So here is a tip how to remember the basic components of the refrigeration cycle. It can be remembered by the letters C, C, L, E, E, right? C stands for condenser, next for compressor, then is liquid, then is evaporator, and then is expansion valve, right? So these all are in sequence. Condenser will come first, then compressor. So alphabetically also among these two, see if you want to differentiate which one will come first as per the sequence. So CON, then COM, right? The same way if we compare the order, alphabetic order of evaporator and expansion valve, so evaporator will come first. So this is the sequence: condenser, compressor, liquid trap, evaporator and expansion valve, right? I hope you people have understood this concept of refrigeration cycle. The upcoming video will be on theory of refrigeration cycle. Hope you people like this video. Do click on the like button, subscribe my channel and share it on social media. Thank you very much.